Okay, here we are on Chapter 1 on functions. This is Section 1.5, Transformation of Functions. Due to the length of this, I'm going to split this into 5, maybe 6 different parts, and so each kind of part will kind of describe one piece of the section here. So the first thing we're going to look at is shifts, and we're going to look at vertical shifts and horizontal shifts from an original function. And so we'll start here with vertical shifts. And so we're given some function f of x. And what we're going to do is we're going to get a new function out, g of x, by adding a k to it. So we'll have f of x plus k, where the k is a constant, and it's going to be a vertical shift of f of x, either going to be up or down. Now, if k is greater than 0, so if we have like a 5 here, plus 5, that's going to be a graph shift up. It's going to move every point up 5 units. Now, if k is less than 0, say we have minus 2 here instead, then we're going to shift all the points down 2 points. And so then we'll have a whole graph shifted down 2. Now, tabular methods for vertical shifts, basically we're going to identify the output row or column, then we're going to determine the magnitude of the shift, what is our k value, plus or minus, and what is the magnitude, and then we're going to add the shift to the value in each output cell, and we're going to add a positive if we shift up and a negative if we shift down. All right, so what we're going to do is give a couple examples here with numbers to kind of explain what we mean here. So here we have some function f of x is given by this, and this is going to be our original x values. And what we want to find is some new function. So we want to find some g of x, which is basically equal to our f of x minus 1. So we have our original function f of x, and then we're subtracting 1 from that. So that means we're going to shift down 1 unit. And so we're looking at the f of x's, and we're just going to subtract 1 from each of those. So our x row stays the same. Our f of x now becomes g of x, and so we're going to subtract 1, so that would be a minus 2, that would be a minus 4, that would be a 3, that would be a 1, and then that would be a 0. Okay, and again, remember, this is a vertical shift down 1 unit, okay? Now, the next time, what we're going to do is we're going to see, well, we're going from some function f of x to some h of x. And we want to know what is the transformation from f of x to h of x. And so we're going to start with basically our function f of x. And what are we doing? Are we going to add or are we going to subtract a thing? Because here we're only looking at vertical shifts. And so we just have to look at the f of x versus h of x. So what did we do to go from a -2 to a -1, or from 2 to 3? Well, if you look at that, basically we're just adding 1 unit to each f of x value. So this is really just going to become f of x plus 1 is equal to our h of x. And so since this is plus 1, we're going to have a vertical shift up 1 unit. Okay, and so we're basically shifting all of our outputs up by 1. Okay, and so that's how we can do that vertically, or table-wise. Now with horizontal shifts, basically again, we're going to be given some function f of x, and we're going to get to a new function g of x. But now what we're going to do is we're going to look at the input values. Remember, over here, we were adding something to the output. This time, we're adding something to the input. And so our standard function notation is going to be f of x minus h. And so here, h is going to be some constant. It's a horizontal shift, basically, from our original function of x. And so if h is greater than 0, we're going to shift right. So if it's greater than 0, so if we have a 2 here, maybe, like example here, then h is 2, and it would look like this. So even though, you know, this time it's the minus h, and so depending on what that h is, 2 or 3 or 4, or if we have a minus, then that becomes plus, and so we have to really consider what our sign is. So the sign should always be negative, so then we just take whatever h is. So if we just have a minus 2, that means h is equal to 2, and we're going to shift that 2 units to the right. So we're going to move the whole graph 2 units to the right. So all the outputs are shifted 2 to the right. Now, if h is less than 0, we're going to shift left. And when we get less than 0, that means we're going to have a minus, a minus. And so really this is x minus a minus 2, if we want to look at it that way, and a minus 2 is plus 2. But here now our h is equal to the minus 2, and that's how we're getting that. So again, we have to think about this as always a negative, and then how does that affect the h? Well, this makes that a negative 2, whereas that one is just a positive 2. So the tabular method for horizontal shifts basically is we identify our input row or column, and then we determine the magnitude of the shift, what is our number, 2 or minus 2, and then we add that shift to the value in each input cell. All right, so let's do some examples here. All right, so here we have f of x plus 1. So if we wanted to, we could rewrite that f of x minus a minus 1. That way we knew that h is equal to a negative 1, okay? And so we're going to basically add that negative 1 to our x column. So what we're going to have is the f of x stays the same this time, but our x value is going to be new this time. So the new x, we're going to take and subtract 1 from here. So minus 2 minus 1 is minus 3. Minus 1 is minus 2. 0 minus 1 is minus 1. 1 minus 1 is 0. And 2 minus 1 is 1. And so that's how we're going to look at the horizontal shifts. We're changing our inputs, our x values. Okay. Now, what about the transformation here from f of x to g of x? Well, the f of x and g of x, notice, they're the same, but it's our x values that are changing. So we know it's going to be some kind of, well, we better write this one here. So this is going to be a horizontal shift left 1 unit, okay, because we have the negative 1, so we're going to go left 1. Now this time we look and we see, okay, our f of x and g of x are the same, so now we have to look at the inputs. So we're going from negative 2 to negative 1, or from 2 to 3. So it looks like what happened here is we have f of x, and now we're going to have minus 1, because now the normal function is f of x minus h, and since we're adding 1 to each x value, then h is equal to 1, and so therefore it's going to be a horizontal shift 1 unit right. Okay, so now we're going to go to the right 1 unit, and so that's what it would look like here, and that's what would be basically our g of x. Okay, so that's what we have to look at in table format. Now we can also combine horizontal and vertical shifts in a given function if they have both of them present. And so basically we have to find what the underlying function is. So basically our f of x, we need to find out what that is. And then we look and say, okay, what is our vertical shift? And basically add those constants to the output. And so we'll move up for positive k, move down for negative k. And so we kind of look and see what that is. We also look and see what our h is, if there's any present, which in this case it says we should. And so remember, the normal format is x minus h, and so if h is positive, we're going to move right, and if h is negative, we're going to go left. And so that's kind of what we have here, and so we're just going to add that to the input. Okay, and so we can do both things, and that's what we're going to kind of do here, is we're going to just really look and describe what the graph of the function here is going to be. All right, so what we have here, this is h is equal to 3, and this says k is equal to 2. Okay, so what does that mean? Well, it means we're going to move up 2 units, and we're going to move right 3 units. Okay, so move up 2 units, that's our vertical shift, and move right 3 units, that's our horizontal shift. Okay, and so that's basically describing what the graph of the function as a transformation is going to be. So we have some function original f of x, and then we're going to move it up 2 units, our vertical shift, and then we'll move everything right 3 units, and that will be our horizontal shift. All right, so what's this one? Well, here, normally, remember, it's f of x plus k. So if we have a negative 4, that means k is equal to a -4, and so we're going to shift down this time 4 units. And so that's going to be a vertical shift. Okay, and that's all we have. F of x stays the same. All we're doing is we're going down by 4 units, and so then it's just 4 units down for all the points here. And now what about this one? Well, remember, it's f of x minus h. We have a +7, so that really is f of x minus a -7. And so here, h is equal to a -7. And because of that, it's going to be a horizontal shift left 7 units. Okay, so we'll move all our points to the left 7 units, and it's going to be a horizontal shift, and that's what we would get with this here. All right, so now I get to try to graph things. It's really not the easiest thing to do on the computer, but what we have is we're given f of x is equal to the absolute value of x. So they give us our original function. So we don't even have to think about what our original function is. And then what we're going to do is we want to find f of x minus 2 plus 4, okay? So with doing that, what we need to do first is we kind of have to think about what is our domain and our range for f of x is equal to the absolute value of x. Well, what does the absolute value of x looks like? Well, if we draw the absolute value of x, say, in purple, basically we're going to get something that looks like that. Again, graphing on here is not quite so easy. And so what is our domain? Well, our domain is all the x values, basically. It's going all the way to the left here, and it's going all the way to the right here. And so our domain is from -infinity to infinity. But what is our range? Well, our range is the y values. Well, it starts here at 0, and it goes all the way up. And it includes that 0 because that doesn't have an open circle there. It's just a point. And so it's going from 0 to positive infinity, okay? Now what we want to do is, well, what is this? Well, this says h is equal to 2, so we're going to go right 2 units. And this says k is equal to 4, so we're going to go up 4 units. Okay, so we're going to have a vertical shift up 4 units, and we're going to have a horizontal shift right 2 units, okay? So let's do just a few points here, and then we can draw the new graph from there. All right, so if we're going to move up 4 units, let's change colors. Let's go to a red maybe. Actually, we can draw 2 graphs. We can do first up 4, and then we'll do a right 2. So if we go up 4, we go 1, 2, 3, 4. And so our new point is here. And this point goes up 4, so it's here. And so basically, our new graph then would look something like that. And that's just for the red. So we'll call this one the red line. And now let's go maybe make it green. And now what we want to do is we want to shift it right 2 units. So every point goes right 1, 2. So we'll start here. If this goes right 2, we'll be here. If this one goes right 2, we'll be there. And so now we'll have something that looks like that. And so that is then when we get to there. And so now what is our domain and what is our range? Well, with the green graph, which is one we're looking at, that's the h of x equals f of x minus 2 plus 4. That gives us a domain, all x again. And so that's going to go from -infinity to positive infinity. But what is our range? It changes. So now our range, it starts here now at 4, and it goes on up to infinity. And so it's going from 4 to infinity, okay? And so this is how you can draw graphs and find your domains and ranges from those. So we started with our purple, which was the original, and then we did the first thing, we did k equals 4, so we shifted up 4 units, and we got the red graph. And then after that, we're like, okay, now let's do the inside part. Let's change the H to 2 units right. And so we'll move everything 2 units right. And so then the green graph is our final representation of our H of X. All right, so that's the end of part 1.